Now it's time to do a chapter project. In this particular chapter project, you're going to learn how to create a computer opponent using a little bit of artificial intelligence. In the game, the player and the computer square off in a game of tic-tac-toe. The computer plays a pretty decent but not perfect game and has just enough attitude to make the game fun. Now, this is a pretty ambitious project, so we're going to take some extra time going through the planning stages of this. It's important to remember that the most important part of programming is understanding the logic and developing that logic, developing a really good roadmap that outlines what your program needs to do, how it's going to do it, and how it's going to get from point A to point B. In the real world, game designers will spend countless hours on concept papers, design documents, prototypes, flow charts, papers full of pseudocode, and they'll do all of this before writing any game code at all. Once the design work is done, then the programmers start their work, which is even more planning, more pseudocode, more concept ideas, more flow charts. It's only after they do all of those technical designs that they start actually coding. Make sure that you plan your programs. I think some of you are sitting down to do these homework assignments and you're just blazing through them without doing any planning beforehand. So you don't really know what variables you need to use, what functions you need to use, how you're going to construct the program. An aeronautical engineer could probably build an airplane from scratch without doing any planning or any drawings. But the airplane might not fly. There's no guarantee that the plane would get off the ground. So they do blueprints, they do prototypes, they do cost-benefit analyses on how they're going to construct that aircraft, how they're going to put it together. And then ultimately they have a set of blueprints for every component of that aircraft. It is a lot easier to throw away a blueprint than it is a jumbo jet, okay? You have to design it first and then build it. And in programming, our designing is done through pseudocode, through development like that. So let's go ahead and start writing out some pseudocode in order to formulate this tic-tac-toe game. Okay, what are the steps that we want the program to go through? First, we want to create an empty tic-tac-toe board. Next, we want to display the game instructions. We need to determine who will go first. And then we want to display the board. Okay, now we've created our board, we've displayed the game instructions, we figured out who goes first, and we've displayed our board. Now we need to have someone, if nobody's won and the game's not a tie, then someone needs to take a turn. So, while nobody's won and it's not a tie, if it's the human's turn, get the human's move. Then update the board with the human's move. Hey, it can really only be the human's turn or the computer's turn. So if it's the human's turn, get the human's move, update the board. Otherwise, calculate the computer's move and update the board with that move. Once that's done, we want to display the board again and switch turns. Once it comes about that it's either someone has won or it's a tie, then we want to congratulate the winner or declare it as a tie. Okay, so that's our pseudocode. It's pretty abstract, and it talks about throwing around different elements that aren't really defined in our minds yet. We have the idea of making a move and placing a piece on the game board, but how are we going to represent the game board? How are we going to represent a piece? How are we going to represent either the human's move or the player's move? And we'll talk about that in the next video, where we'll do some additional planning, figuring out how we're going to display our game board and what functions we need.